Good day, everyone. I've come once again to teach you today. The topic we have on the board is friction. Today, we want to discuss friction. As you know, friction is what? A kind of force. That's why sometimes we call it a frictional force. Okay? So, follow me. Let's go and do it. So, follow me. Let's go and do it together. Let's go. All right, we have this friction. When you hear friction, what does it mean? Friction simply means what? An opposing force. An opposing force. All right. When you say opposing force, what do you mean by opposing force? Opposing force simply means that this friction is trying to tell you not to move in the direction that you're supposed to move. Instead, that you are going to move in opposite direction. Meaning that if you want to move forward, frictional force will be acting backward. If you want to move towards the left, it will be acting towards the right. If you want to move towards the right, it will be acting what? Towards the left. Opposite direction to the um, normal direction that you want to follow. All right. And the one thing about this friction is that it occurs between two surfaces. When you have only one surface like this, you are not going to have any frictional force there. Is it clear? Frictional force occurs when a body is moving on another body and they will have contact. For example, if you have my palm like this, I'm doing like this, you notice that this one and this one, they are in contact. So in between these two, you have what? Frictional force. All right. So when you have your foot and you have what? The ground, they are two surfaces. So we have your foot and we have what? Ground. In between, you have what? Frictional force. When you have tire of a vehicle and you have what? Ground, that the tire is standing, we have two surfaces. So in between the tire and the ground, you have what? Friction. Is it clear? So when you have screw and when you have bolt, or when you have bolt and nut, or when you have screw. Okay, let me use bolt and nut. When you have bolt and nut, they are two surfaces. So in between the bolt and nut, there will be what? Friction. When you have wall and you have what? Nail, you want to hammer the nail into the wall. You have the surface of wall and you have the surface of what? Nail. In between the two, you have what? Friction. So this friction acts in between what? Two surfaces that are in contact. In between the two surfaces that are what? In contact. Meaning that if one body is moving on another surface, the friction will act in opposite direction to what? To the normal direction of that body that is moving. Can you see that? So that is how it's done. So the friction acts what? In opposite direction. For example, you have this body like this, and you have another one like this. Can you see this? This one is shaded to show that it's different from the other one. So assuming that this unshaded one, is moving towards this direction. Can you see that? So this one is moving like this and is in contact with this one. Can you see that? So it will be a kind of rolling over this. So this frictional force will be acting on this surface that they have contact, and it will acting towards this what direction. Can you see this one is moving towards this side, but this one will be moving in opposite direction. So that's why we say that the frictional force is what? It's an opposing force. It stops us from going the direction that we want to go and say, let us go to the opposite direction. So we have friction moving in opposite direction. So we have surface 1 and we have what? Surface 2. Can you see that? And this thing is moving towards this side. And look at the contact where they have in contact. Can you see it? All right. So this thing is moving towards this side. You notice that the frictional force will be moving this side. Can you see it? In opposite direction. That's why we say that it is an opposing force. All right, one thing you need to know about friction is that it adds when you have two rough surfaces. When you have two rough surfaces, that is where we have what? Friction. When you have rough surfaces, you have it more. But when the two surfaces that are in contact are smooth, that means that you have little or no friction. You have little or no friction. So when the surface is rough, it will increase what? The chance of what? Friction. But when the surfaces are smooth, it will reduce it. You have little or no friction. When you have this contact surface being smooth, little or no friction. When you have it being rough, you have high friction. All right. So that's why when you want to reduce friction, what you do is that you make the two surfaces in contact to be what? To be smooth. So by reducing the roughness of the two surfaces that are in contact, you will be doing what? You'll be reducing what? The friction. That's why when you apply lubricant, here, what will it do? It will reduce the roughness of these surfaces that are in contact, and therefore it will be reducing what? Friction, and so many other ways of what? Reducing friction. So rough surfaces favor friction, while smooth surfaces does not favor what? Friction. All right. We have types of what? Friction. Types of friction. Types of friction. We have two types of friction. We have the one we call static. We have static friction, and we have the one we call dynamic friction. All right. So static friction is talking about a body that is at rest. Is it clear? A body that is at rest, that is where static friction comes to play. For example, when you have a vehicle, maybe something is wrong with the vehicle, it's stagnant. That means that the vehicle is not moving. So if the driver of that vehicle calls one person, especially a little child, to come and push the vehicle, you notice that the child will come and be pushing the vehicle, but the vehicle will not move. It is not that the child is not exerting force on the vehicle, but the child is not exerting enough. What do I mean by enough? Every stagnant object has what we call what? Static friction. Certain amount of what? Force. And for you to make that object to move, you have to at least apply up to that amount of force to overcome the effect of friction. For example, if that vehicle that spoiled, that its static friction is what? 7 newtons. Can you see that? That vehicle that is parked, its static friction is 7 newtons. So if you come and be pushing it, if you are able to exert 5 newtons on that vehicle when you are trying to push, that means that the vehicle will not what? Will not move. Why? Because you have not exerted enough force that will overcome the effect of what? The static friction to enable the vehicle to move. So this static friction simply means the opposing force that must be what? Overcome before the before a body that is at rest will start moving. So if that vehicle that is parked, or that stationary object, that stagnant object, you are pushing or pulling or trying to make it to move, if its static friction is 7, that means that at least you have to exert a force of what? 7 newtons before that vehicle will start what? Moving. All right. Why? Because this 7 newtons that you have exerted on that object will do what? Will be used to overcome what? The static friction, and therefore it will now have every tendency to what? Move. Can you see that? So if you have a lorry or a truck or a vehicle, you people are 2, 3, 4, you are trying to push it but it's not moving, what will you be doing? You'll be asking for more people to come and join you to push. You are trying to gain more force in order to overcome what? This static friction of that vehicle that you are pushing. Immediately that aggregate of force that you people are applying is up to the static friction of that stationary object, that object will start moving. So this static friction, it is what? The opposition force, that is frictional force, that has to be what? Overcome before a stagnant object will start what? To start moving. All right. So it has to do with when an object is what? Stationary, when an object is at rest, when an object is stagnant, when an object is not moving. So that is the amount of force or opposition force that has to be overcome before the object will do what? Will move. So next time, if you are pushing a vehicle and it's not moving, just know that you are unable to supply amount of force that will overcome what? The static friction of that what? Stationary object in order to make it to what? Move. So what you are going to do is that you call your neighbors so that they will join you, so that you people will produce aggregate of forces that will be what? That will be up to at least up to the static friction in order to overcome the effect of static friction and make the object to what? Start moving. So if you push that vehicle, it fails to move, it simply means that you are unable to supply force that will be able to overcome the static friction. So static friction has to do with object at rest. It is the force that opposition force that has to be overcome before an object at rest will start what? Moving. All right. So what about this dynamic friction? This dynamic friction simply means the force or the friction that has to be overcome for an object to start moving in what? Constant speed. For an object to start moving at constant speed, you have to overcome what? The dynamic friction. So what you need to understand here is that static friction has to do with what? An object that is at rest. So the opposition force that you have to overcome for it to start moving at all. Then dynamic friction has to do with object that is already moving, object that is in motion, the force that you have to overcome for this to start moving at constant speed. All right, so that is it. Right, let us talk about calculation of what? Friction. All right, like I said earlier, friction is what? Friction is a kind of force, meaning that its unit is what? Is Newton. It's a type of force. Its unit is what? Newton. All right, so mathematically we have friction. We use F to denote it. Mathematically we have that friction, which is F, is equals to, we have this neon times what? R, like this. All right, F here, F means what? Friction or frictional force, whichever one. All right, while R means what? Normal reaction. R means normal reaction. All right, then this neon, it means what? Coefficient. Coefficient of friction. Coefficient of friction. That's the meaning. Coefficient of friction. All right. All right, when you look at this now, you notice that the unit of friction is what? Is Newton. Can you see that? Again, the unit of normal reaction is also what? Is Newton. Can you see it? So if friction has unit of Newton and normal reaction has unit of friction, has a unit of Newton. All right, I don't have much space here. Let me continue up here. I want to find the unit of coefficient of friction. So I have F, which is what? Newton, like this. I have neon, like this. Then I have normal reaction, which has unit of this. Can you see that? All right, so I want to find the unit of this. So the unit of this cross is multiplying this one, crossing over here, it will start dividing. So we have that F, which has unit of this, will be divided by normal reaction, which has unit of this, and that will give us what? Neon, which is a coefficient of friction. Can you see it? So you are dividing friction by what? Normal reaction. By division, you notice that Newton will divide Newton. Can you see? So what you have dividing now should be ordinary numbers. Can you see that? And that makes what? Coefficient of friction to be dimensionless. That's why we say that coefficient of what? Friction is what? Dimensionless. We have it to be what? Dimensionless, meaning that it does not have unit. Why? Because it is the ratio of two forces. Is it clear? Sometimes in an exam, they will ask you, why is it that coefficient of friction does not have what? Any unit. The reason is that it is what? it is a ratio of what? Two forces. Can you see that? A ratio of two forces. Right? The two forces we are talking about here, we are talking about friction and we are talking about what? And the normal reaction. Can you see it? Friction and what? Normal reaction. All right. So that is it. So why coefficient of friction does not have unit is that it is a ratio of two forces. That is ratio of friction to normal reaction. The friction has unit of Newton and normal reaction has unit of Newton. Newton will cancel Newton, making it to have what? Ordinary number. So reason is that it is a ratio of two forces. And being ratio, the units will cancel each other. You will be left with ordinary numbers. That's why it is what? Dimensionless, and that is why it does not have any unit. All right, having done this, let us solve some examples that will enable you to understand this topic very well. Let's go. Example 1 says a block of wood weighing 4 newtons is placed on a horizontal table. It is then pulled by means of a spring balance. All right, so we have solution like this. Assuming that we have our horizontal table like this, can you see our horizontal table here? They said a block of wood weighing 4 newtons is placed on a horizontal table. Assuming that we have the block of wood here and it is weighing what? 4 newtons. Can you see it? It is weighing 4 newtons placed here. Then it is then pulled by means of a spring balance. Look at it here. It's being pulled like this. You have spring balance like this. Can you see the spring balance here? All right, so we have, it is being pulled by what? Spring balance. Can you see that? All right. Attached to one of its ends, I have drawn it here. The block just begins to move when the spring balance records a horizontal force of what? 2.5 newtons. We have like this, 2.5 newtons. That is what this thing records. That is the force that has been what? Applied. Is it clear? The first question says you should find what? The coefficient of static friction. The coefficient of static friction. All right, so we are looking for this coefficient of static friction. That is what we are looking for. All right, there was something I said that the force that you have to overcome before an object will start moving, that is what we refer to as what? Static friction. So if this spring balance will record 2.5 newtons before this object of weight 4 newtons will start moving, that means that the static friction of this object is what? 2.5 newtons. So if it will record 5 newtons before it will start moving, just about it will start moving, that means that the static friction is what? 5. If it records 12, that means that the static friction is what? 12, and so on and so forth. That is the force that has to be overcome before this object will start what? Moving. So if we have something like that, that means that the friction, which is static friction this time around, because this object is at rest, that means that the friction will be what? It will be 2.5 newtons. Can you see that? All right. Then when you talk about an object that is on horizontal position, just like we have here, when an object is on horizontal ground like this or horizontal level, its weight is equivalent to its what? Normal reaction. Its weight is equivalent to its normal reaction. That means the weight, which is like this, is equals to what? R. And they gave us that the weight of this object is what? Is 4. So that means that its weight is what? Is 4. And its normal reaction is 4 newtons. All right. So I told you earlier that frictional force is equals to, we have coefficient of static friction times what? Normal reaction. All right. So making coefficient of static friction subject of the matter, this R is multiplying, coming here it will start dividing, so we are going to have F over what? R is equals to, we have coefficient of what? Static friction. Can you see that? All right, I don't have much space here. Let me try to see if I can solve it here. All right, substituting here, I have frictional force to be what? 2.5. So I have that coefficient of static friction is equals to, I have it to be 2.5. That is the value of frictional force over value of normal reaction, which is what? Which is 4, like this. Can you see that? All right, so what will I do? 4 will divide itself. When 4 divides itself, it will give me 1. Dividing 2.5, dividing 2, it cannot go. I'll put 0, put point. These two will be added in front of what? 5, making it 25. When 4 divides 25, it will give us 6, remainder 1. Can you see that? That 1, add 0 at the back of it, it will become 10. When 4 divides it, it will give me what? It will give me 2, remainder 2. 0, add 0 at the back of 2, making it 20. When 4 divides it, it will give me 5. Can you see that? So it means that the coefficient of static friction is what? 0.625. Can you see that? I divided it without using calculator. But if you press your calculator, you can easily get it. Just press 2.5 divided by 4. It will give you this. But in case you don't have calculator, just divide 4. It will give you 1. When 4 divides 2, you cannot go. Put 0. Put dot. Carry that 2. Put in front of 5, making it 25. When 4 divides it, it will give us 6. Remainder 1. That 1, add 0 at the back, it will become 10. When 4 divides that 10, it will give us 2. Remainder 2. That 2, add 0 at the back, it will become 20. When 4 divides it, it will give us 5. So, like I said earlier, coefficient of friction does not have what? Unit, because it is ratio of two forces. Right? So, that is answer to question number I. I don't have much space here, so let me solve II here. II says, what is the frictional force when a horizontal force of 2.0 newtons is recorded by the spring balance? All right, remember from what they said earlier here, that this object was about to start moving when this recorded what? 2.5 newtons, showing that what? This is the static friction. That is the force that has to be overcome before this object that is at rest to start moving. That is static friction. All right, it means that anything less than this, supplying anything less than this object will not move. If you supply 2.4, it's not going to move. When you supply 2, it's not going to move. Supplying anything less than this, even if it's small fraction of force less than this, it cannot move. Until you supply this object cannot move, because that is the force that you have to overcome before it will start moving. All right, so you telling us here that this thing will record 2.0, it means that this object will not move because you have not supplied up to 2.5. Is it clear? So what actually happens is that if you supply anything that is less than the static friction, what it means is that the object will also counter supply the same amount of what? Force in opposite direction. That is the friction, in order to what? Balance it without allowing it to move. For example, since the static friction is 2.5, when you supply 2, it will just do what? Supply you 2 back in opposite direction, so that it will balance it and it will remain the same. So when you apply anything under the static friction, that's less than the static friction, the object itself will supply you the same amount of force backward, that is the friction, without allowing that object move until you get to what? Amount of static friction. That is when the object will start moving. So when this thing records, when this recorded 2.0, it is not up to this. That means that this object will also, in this direction, supply what? Supply the same 2.0. That means that the frictional force here should be what? Should be 2.0. Because it's not going to move. It's going to supply it back in order to balance it. If you supply 1.8, it will give you 1.8 back in order to balance it. That means that the frictional force will become 1.8. If you supply 1.5, it will give you back 1.5. If you supply 1 Newton, it will give you back what? 1 Newton. That means the friction will be 1 Newton. That means the friction will be 1.5. That means the friction will be 1.8. That means the friction will be what? 2.0, as the case may be. As long as the force that you are exerting is not up to the static friction, which is 2.5. I said earlier, we have a truck or a vehicle and you are pushing it alone, you notice that you will not be able to push it. Why? Because you cannot exert up to what? Static friction, where the object will start what? Moving. So what actually happens is that when you exert that amount of force that you're exerting, that object, which is the car or the vehicle, whatever, will give you back the same quantity of force that you are exerting in opposite direction. That means that that force will be opposing your push. And we said that friction is what? Opposing force. So that means that if you put 2 newtons, the object will give you what? 2 newtons as opposing force. That means the friction that object will give you is what? 2 newtons. If you give 5 newtons, the object will give you what? 5 opposing newtons. Can you see? That means that the friction will be what? 5. So for this thing not to be up to static friction, that means this object will give it back to this, and therefore the friction will be what? This 2.0. So here they say, what is the frictional force? We say that the frictional force is equals to what? The same 2.0. Can you see it? 2.0. It will give it back. It will give it back to this without moving, so that it will balance. So that is it. I believe that you enjoyed the way I just solved it. Remember, this is Engineer Kenneth Tutorial. Subscribe to this channel, follow my Facebook page, share this video so that it will get to the right students that need to acquire this knowledge in order to get educated. Once again, thanks for watching this video. Bye.